Hey everybody, welcome back to Beyond Basics with Madiha. In today's video, we're cracking one of the most asked DSA problems, to sum. So stay tuned till the end of the video. In case if you're new here, make sure to like, share and subscribe to get access to my DSA playlist. Alright, without any further ado, let's get started. Now, according to the problem statement, we're supposed to deduce the indices of two numbers from this array such that when you add the two numbers, their sum has to match with the target. Now, if you take a closer look at the array and look at the numbers in deeper dimensions, you'd realize that 2 and 7, when you add 7 plus 2, the sum is 9, which matches the target. And since we've deduced the two numbers, now what are we supposed to do? We are supposed to return the indices. Now, number 2 is at index 0 and number 7 is at index 1. So this is going to be the output. We've got the two numbers. When you add the two numbers, their sum is matching with the target. Once you got that, boom, this is the only output that you need. The indices is what you will return. So we have understood the problem statement. Now let us figure out on how do we solve this problem statement. How do we approach this problem? Now, approach 1 is always going to be the brute force approach. Now, if you think about how to solve the problem, the very first solution that might strike your brain would be the brute force solution, where you try all permutations and combinations. That is, you will try with every possible pair. You will take one number, compare it against all the other numbers, and check if those two numbers, when you add, if their sum is equal to the target or not. All right, that is the basic idea that any person might come across. Now, how do we solve this using the brute force technique is something of this kind. So we have two loops, outer loop and inner loop, and we start with the first number. So let us have this array as well. So we have 2, 7, 9, 11. Now, what are we doing? The outer loop would point at index 0 and the inner loop will keep moving. Now, what are we doing is we are checking 2 against all the numbers. That is 2 plus 7, 2 plus 9, 2 plus 11. And again, once we don't find any result, then we move I to 7. Then again, the same process we repeat with all the other elements. That is 7 plus 9, 7 plus 11. Likewise, until we get the solution that we need. Until then, we keep trying and moving and try every possible permutation and combination. So we have the outer loop, we have the inner loop, and what are we doing? Num of I plus num of j. If that is equal to the target, we return I and j. Okay. In case if it is not, then we keep moving j. So 2 plus 7, yes, it is equal to the target. So we return I and j. So I is 0, j is 1. Now let's assume 7 was not here. 7 was at the last position. And in place of 7, let's put 11 here, just to understand the brute force. So we try 2 plus 11, that's not equal to the target. So what do? We move j plus plus. Now j is at 9. 2 plus 9, no, it is not. So we keep moving j again, 2 plus 7. So in that case, 2 plus 7, we got our target and we return I and j. Now, let's say if 2 was not here. Let's say if 11 was here and if 2 was here, then in that case, you will still have to continue doing the search. You might not get it in one iteration. So 11, we start I at 11. 11 plus 2, not equal to the target. 11 plus 9, not equal to the target. 11 plus 7, not equal to the target. So now what do? One iteration is complete. So again, we move to the next iteration where your I value is 1 and your j value will be I plus 1. So we again start with 2 plus 9, not equal to the target. 2 plus 7, which is equal to the target. But if you see, this is time consuming. It depends on where your 2 or 7 is positioned. Let's say if we have an array of this sort, 11, 10, 9, 3, 2. In this case, this might take 3 iterations. I'm sorry, let us make this as 7 instead. Okay, so this might take, in the third iteration, we'll get 7 plus 2. Suppose if 7 was here, Then in the fourth iteration, you get 7 plus 2. So likewise, it depends on where you place the numbers, the exact numbers. But still, one thing you'll have to understand is any solution that you design has to be so robust that it has to come across all the constraints. That is, no matter where you position it, it has to still give you result instantly. That is how you design the solution. But this is the brute force technique where we have two loops. And we try one number against all the numbers, and then we move on again, pick up the new number, and again try that number against all the numbers. Using this technique, we can reduce the solution, but the only constraint here is it is time consuming. If you see the time complexity, it is big O of n square, which is not an optimized solution, n square, because it has two loops. But what if you have to deduce, make it from O of n square to O of n? How do we do that? How do we go about that? So this is how you'll have to think, because any solution that you design cannot have an exponential time complexity. Make sure you have a linear time complexity, so that the more less time consumption it has, the better it is. Okay. So but you always have to start from brute force, so that once you design a brute force technique, you'd understand the loopholes and you'll come across how do I make it more better. That is how you'll think. So the very first thinking was it has two loops in the brute force. Now, if I have to optimize it, I don't want two loops, rather I would stick with one loop. Now, if I have one loop, which means I can only traverse the array once. There's no multiple traversal of the same array. Now, if I have to traverse array once, then how do I figure out the two numbers within just a traversal? This is how you'll have to think. When you come across approach 2, that is only one traversal. Now, when you only traverse the array once, which means you need to store the values that you've crossed in an array into something, right? Suppose if you have an array that is, let's say 2, 5, 7, 11, 9, something of this kind. So this is your array. Now, after this array, what are you trying to do? If you traverse the array once, that is, once you cross 2, you are at 2, and once you cross 2, there's no going back again. It's always moving further. It's always moving forward, not going backwards. So if you've crossed 2, you cannot go back to 2 again. If you've crossed 5, you cannot go back to 5 again. If you've crossed 7, there's no going back to 7 again. So, but if you're not going back, which means you need to store these numbers somewhere. That's where HashMap comes into picture. When you come across problems where you might need to go back, but if you go back, you will make use of two loops. But if you don't want to if you don't want to use the two loops, but you also want to remember the numbers you've crossed, then you need to store them somewhere. That's where HashMap comes into picture. Numbers again and again, what we do instead is we will store the numbers that we've already seen in a map. And for every number I come across, there's one thing I do. That is, I figure out what number with this current number do I need, so that when I sum the two numbers, I get this target. Okay. Now, the number that I need with this number, we will calculate it something like this. Now, suppose, let's say, we have the array 2, 5, 7, 9, 11. And the target is 9. So I start with 2, and now I got one number. Now there's one more number that I need, such that when I add this, what is the anticipated output? When I add the two numbers, the result or the sum has to be the given target, that is 9. And one number I've already got. The second number is what I'm going to find. So the second number we're not sure, let's keep it as x. But now, if you see this math, you can calculate x when you shift 2 to the other side, right? Simple math. That is, x is going to be 9 minus 2. That is how we are going to calculate it. 9 we already have, which is the target. Okay. 2 is going to be the current number, num5, which is this. And what do we need? We need that missing piece, that is x, which we call here as complement. Okay, that is how we are going to solve this. I go here 2 plus x is what I need. X I don't have. So 9 minus 2 is going to give me 7. So I need the number 7. Okay. Now what I do is I go to the map and I see if 7 is there in the map. If 7 is not there in the map, which means we cannot find. So what do we do in case if 7 is not there? We add the current number in the map. That is, now my map will have the number 2 with the key. The key is going to be the current number and the value is going to be the index of the number, that is 0. Then I move further to 5. Now 5 will be 9 minus 5, which is going to be 4. I go back to map, I see 4 is not there. So what do? I include 5 and the index of 5. That is 1. Now I see 7. Okay. So 9 minus 7, we have 2. So this is something that we have already seen. Now let's say if you wouldn't have saved the numbers that we've already seen, then we would have never deduced the expected output with one traversal, right? That is why if you have to store the numbers that you've already seen, that's why we make use of this hash map, so that we can finish and solve this in the expected time complexity, that is big O of n. So we have 2. Now we want 2. The missing piece here is 2 because 9 minus 7 is 2. Now we look for 2. 2 we do have in the map and we got the index as well. So this index is 0 and the current index is I, which will be 2. This array is what we return and this is the anticipated output. Simple as that. Now let's understand this better as we move on to the other slides where I would explain you more and we would code the solution as well. So this is pretty much what we're doing. We need a hash map so that we store the number and its respective index. And we loop through the array. For every number we come across, we calculate the complement. Simple math. And if the complement exists in the map, we return both the indices. Otherwise, we store the current number in the map and we keep moving forward. Now let us understand on how do we code this. Okay, let's try to code the problem. And if you follow this approach, what is going to be the time complexity? Big O of n, because there's only one loop, there's only one traversal. Multiple iterations, multiple loops, we avoid. Let us look into the code now. Need a complement, int complement, and we initialize it to 0. And we need a hash map to store the numbers that we've already seen. A hash map of integers. Let's declare the hash map as map. Okay. And we start the for loop. For int I0 until we reach the last element of nums. I plus plus. And at every number, what we do? We calculate the complement. Complement has to be target minus of the current number, which is nums of I. And the next thing we do is look for its existence in the map. So once we figure out the complement, we see if map dot contains key. Okay, we look for the key, which is equal to complement. And if it exists, we just return the array, return new integer, return with the values, that will be map.get of complement. We would get the index plus the current index. If not, if it does not exist, then what do? We store the current number, that is nums of I, with the current index. And in case after the complete traversal, we fail to reach the pair, let's say if there is no such pair in the array, then we just return an empty array. Since we have to return an array, right? It's not void. So we have to return something even if we don't find the result. It has to be an empty array. Something of this sort. Okay. A complement, a map, a traversal, reckoning of the complement, checking the complement existence in the map, creating the array of indices and returning it. If not, shoving the map. In the worst case, that is, if we don't find the pair at all, just returning an empty array. Let's try to submit this. Okay, cool. So if you see here, the runtime in 2 milliseconds, we've cleared 63 test cases. Okay, that is the optimal solution. Now, in case if you would have used that two for loop solution here, we must have not, passed all the test cases. We must have not cleared all the test cases. It's very important for you to clear all the test cases. Optimized solution is very much important. Okay. All right. That's it for today. This brings us to the end of the video. If you found something knowledgeable, then do like, share, and subscribe to stay tuned. And we shall see you on the next video of DSA.